All right, we're going to take a look at version 2 of the exam. I'm not sure which version you had, so you'll need to verify with the answer key in the PDF file. So we want to know what's happening in this position versus time graph, and we notice that the slope of B is steeper than A. And what that indicates is that B is clearly moving faster if this is a position versus time graph. And we're moving at a steady speed. And notice that we're moving forward since the position is actually increasing as a function of time. So that means that rules out pretty much A and B and E, and that leaves us with choice D as our correct answer. Now in this next position versus time graph, we're moving backwards, and we're moving at a steady speed. So let's eliminate all choices that talk about moving forward. So that doesn't work. And that one doesn't work. And we're definitely not slowing down since the slope is steady, constant. So we're actually starting at a negative position here. And we're moving backwards at constant velocity. So that's how we get choice D. Now for this particular velocity versus time graph, because the velocity is negative, that means we are moving backwards. And since the velocity is not changing, that means it's at a steady speed. So that means choice B is our logical choice. Now, for questions 4 through 7, we want to know what's happening in this position versus time graph, and we want the velocity. So to get the velocity from a position versus time graph with constant velocity, we need to get the slope. So let's get these points here. This is 0 to 100. And this is 8, 0. So the slope is going to be, well, I could use y2 minus y1 over x2 minus x1 as my general algebra formula. But for our speed, that's actually, remember, position is the x variable and time t, which is a little bit confusing if you haven't had physics before, but we're now familiar with this, having had a semester of physics. We're going to have x2 minus x1 over t2 minus t1. And that's going to give us 0 minus 200 over 8 minus 0. And that's how we're getting negative 25 centimeters per second when we plug in this number. All right, now question number 5. What is the object's position at 6 seconds? Let's just check the graph and see. So at 6 seconds, we're at 50 centimeters. Sorry. Hopefully I got my units right. Yes, 50 centimeters. And where will the object be after 38 seconds? So we actually need an equation of motion for that. So we notice that the initial position is 200 centimeters. And we know that the slope is negative 25 centimeters per second. See work below. So when we write down the equation for this graph, which is the position equation as a function of time, this is the general formula that we used for the Buggy Lab formula. And in this specific case, it's going to be x is negative 25t plus 200. All that's left to do is to plug in 38 seconds into our formula. So let's go ahead and do that now. And the answer that we'll get for the position is negative 750 centimeters. And that's where we end up. Finally, for number 7, which of these would best represent the velocity versus time graph for the buggy? Well, we're moving backwards at a steady speed, and I hope by now we're clear that that would be choice D. In the next few videos, we'll actually finish up a few more of these multiple choice problems. Hope this was helpful.